So let me start out by talking a little bit about cognitive load and mathematics. For those of you who took my previous class, you've probably run across cognitive load, and those taking this class have probably heard it in other contexts as well. But let me just briefly talk about it in the context of mathematics to help us frame interventions to support students who are struggling with math and to really understand why they work and which ones will work for which student profiles. So let's do a quick reminder of the different types of cognitive load. On the one hand, we have what's called an extraneous load, and these are loads that are part of the learning task that the student is working on. So whether it's a problem set or a simulation or a word problem or a classroom activity, it's parts of the task that take up um, cognitive resources, but they're not integral to your learning goal. And we'll talk a little bit about defining your specific learning goal in a minute. So, for example, you can think of spelling in a critical thinking essay, or for math, reading in an algebra word problem. Reading is not typically a learning goal in an algebra classroom, and therefore you would consider that an extraneous load. And you can imagine multiple student profiles for whom reading is an effortful activity, such as students with dyslexia, but also English language learners and so on, or those who are not familiar with the language of formal mathematical or classroom mathematics. Um, those students may be struggling and it may require significant cognitive effort or tax their working memory to deal with those extraneous loads. On the other hand, we have intrinsic loads. These are the core loads we actually want the students thinking about and struggling with. We want their resources focused on this part of the learning activity. And so, again, if you're looking at that critical thinking essay, you want that deep analysis. When you're working on an algebra word problem, your goal is probably fostering algebraic reasoning or assessing algebraic reasoning in that student. So ideally, very little of their cognitive resources are put towards reading, and most of their cognitive resources are put towards algebraic reasoning. That's what we want to try to maximize. And no matter what format you use, whether it's a problem set or an applied problem or another activity, some element of it is going to be an intrinsic load, and some element of it is going to be an extraneous load. Uh, so when the extraneous load plus the intrinsic load is manageable, so it doesn't exceed a student's working memory capacity, students perform well. They're able to manage that extraneous load because it's not overwhelming for them, and the intrinsic load is appropriate to their current ability level, so they can learn from it and they can perform the task. That's the ideal situation. However, if on the other hand the intrinsic loads are too high, so if the elements of the task are simply beyond the ability level of the individual that they're assigned to, or if the extraneous load, on the other hand, is really high, if we give a very language intensive word problem to a dyslexic student, then their work is going to be slowed, or they're simply not going to be able to complete the task successfully and learn from it. Uh, so this is at the heart of interventions aimed at improving students' performance in the math classroom. So if we're looking at students struggling in the math classroom, and again, I think you've looked at this in other contexts, but any weaknesses in memory, attention, or executive function is going to limit the total amount of working memory that those students have. Um, so a student with ADHD might struggle with math because they have a more limited working memory capacity available to them during that math task, particularly if that math task is not particularly engaging or interesting for the individual. They're going to dedicate fewer cognitive resources to it. We talked about the impact of language processing challenges and whether the student has dyslexia or struggles with auditory processing or English isn't their first language. But if that's effortful, that's going to impact their math performance. Um, for those students who have poorly automatized skills. So in mathematics in particular, skills build on top of each other. So as students develop proficiency in math, um, the intent is, or the goal is, that more basic skills become automatized. They start becoming processed fluently and automatically, and students don't have to dedicate much cognitive resources towards processing them. So, for example, as students transition from addition and subtraction to multiplication, the hope is that addition and subtraction become increasingly easier for them through practice and exposure. That's sort of the traditional view. And as they develop and automatize those skills over time, you can take on new, more challenging work because the more basic work now is easier and more automatic for you. That's also an argument for strengthening mental math, for example. Uh, and then we have that anxiety affective element to it that's so common in the mathematics classroom. So many people uh, uh, have a lot of negative associations with mathematics and mathematics education. That it in and of itself imposes a cognitive load. So the stress, anxiety, and worry around math, numbers, math tests, and so on impose a cognitive load that limits the working memory of the students working on those problems and causes them to perform poorly in math, which then increases their anxiety, and you see a vicious circle there that often drives students to simply disengage from math. So, what can we do to help students who are struggling? Students who are overwhelmed due to limited working memory capacity or very high extraneous loads or intrinsic loads that are beyond their ability level. We can help automatize skills. So for those students who can develop fluency in skills, that's something we can work on and we can strengthen. We can help students address some of those affective confidence issues, and often uh, helping them experience genuine success by providing appropriate scaffolds and supports that allow them to succeed can reverse that negative affect where success begets more success. Um, we can, for those students who will not automatize skills, teach them effective strategies and use um, approaches such as the use of manipulatives, hands-on projects, and so on to overcome weaknesses that may be associated with number sense or language processing. Uh, and essentially address those cognitive loads. Um, and we'll talk specifically about those strategies and supports in the next video. Um, but in the mathematics classroom, I also want us to be aware of the fact that there are a number of sources of cognitive load for the student that we're rarely aware of. We are often asking students to develop proficiency and fluency in decoding a whole range of new symbols, be it the numbers themselves, which students who have dyscalculia often cannot fluently decode, or the operations. So students are often learning new operations, learning definitions of new operations at the same time that they're undertaking these other cognitive loads. So we have new language, new symbols, new operations that the students have to develop fluency in. At the same time, we are introducing them to formulas and computational algorithms or procedures that they need to follow to solve certain equations. And we want them to develop this computational fluency with these procedures. While concurrently developing a deep understanding of the underlying concepts represented by these symbols and these operations. So really, in fact, we're asking students to do all three at the same time. And for the vast majority of learners, this is overwhelming. They don't have the fluency with symbols and the new specialized language. They're still struggling with procedures and formulas and so on and how to apply them. And to ask them to understand a brand new concept at the same time is really overwhelming and becomes especially challenging for students who may have a learning difference that impacts one of these domains. So, for example, um, many students with dyscalculia struggle with that number sense, the symbolic decoding. Many students with ADHD and executive function issues struggle with with following procedures that are necessary to solve an equation and not skipping or overlooking steps and staying on task. Uh, and often the conceptual understanding piece is the piece that ends dropping off in an effort to get students to apply the right formula and remember the right vocabulary. Uh, but I would argue that the conceptual piece is likely one of the most important pieces for us to focus on.